The world around us is filled with important unanswered questions. Try this one for size. What is all that math we learn in high school good for anyway? As it turns out, all math, from arithmetic through calculus and beyond, can tell us a lot. For instance, which recycling program is best for my city? How will a new flu outbreak affect the US? Or even, which roller coaster is the most thrilling? These are real-world scenarios for which math modeling can provide understanding or solutions. Modeling is a process that uses math to represent, analyze, make predictions, or otherwise provide insight into real-world phenomena.
When you're analyzing and looking at the models and everything, you get to see how these numbers are used and how you can actually apply the math that you learn.
In my opinion, anything in our life can be modeled mathematically, so we can always find a pattern in our life.
Here's how it works. Start with a basic definition of your problem.
If you define the problem, research will become a lot easier, and you'll actually understand what you're doing rather than just mindlessly researching and having so much research but not really knowing how to apply that research.
To simplify the scope of the problem, you'll need to make a few assumptions.
If you make assumptions, you can get rid of some extraneous and insignificant factors, so your model really only considers the most important variables.
Next, define your variables.
If you're trying to make a mathematical model, you are trying to create an equation of some sort that incorporates certain variables. By defining those variables, by figuring out what those variables are, especially early on, you know what you're looking for.
Now it's time to use the math that you know to build a model. This is where you'll first see your solutions.
We just used algebra the entire time, so we didn't have to go into calculus or differential and integral equations. We just make a couple of assumptions so that you can use easy algebra instead of taking some really long, complicated method.
Next, you'll analyze your model to make sure it works. Ask yourself, what can I learn from my model? Does it answer the original question? Does the answer make sense?
The analysis is just essentially looking at your data and showing how your data correlates with what the hypothesis that you're giving.
Finally, you'll report your results.
Model is more than just math. It's what assumptions we made, how we came up with those assumptions, and the justifications is extremely important.
Math modeling can help us answer big, messy questions about things like recycling options, spread of disease, and even the thrill factor of roller coasters. So now, instead of asking, what is all this math good for? The question becomes, what can't we figure out with math? For more information on the math modeling process, visit m3challenge.sciam.org.